Hello students, today we are going to learn about Fourier series. So in this series we are going to about Fourier analysis in which we will focus on Fourier series and Fourier transform. So today I am going to discuss about the basics which we will be going to use in Fourier series. Then after we'll focus on formula for Fourier series and what are the parameters that we'll be going to find in this. Then after that we'll have a look on some problems of Fourier series. So let's start with the basics. First of all, we should know about periodic function because the functions that we are going to solve in Fourier series, those functions will be periodic functions. So, what is a periodic function? A periodic function is a function that repeats its value after a regular interval or period. It means like whatever the functions that we have given, then that function will be repeated after regular intervals or periods. Here I have taken an example that is x. Then this function will be x is a periodic periodic function which will be going to repeat its value after 2 pi. You can see on the graph that 0 to pi there is a graph, and after that pi to 2 pi the same graph will be getting repeated. So this function is getting repeated, so this function is said to be a periodic function. You might be thinking that the function x is not a periodic function, but we can make any function as a periodic function, and it's depend on us on how many intervals we are making the function as periodic function. Here I have made the function a periodic function after 2 pi interval. You can see that after 2 pi interval this function will be repeated. Like will be getting the same function after the 2 pi interval. So this function is said to be periodic function. Okay. Then after have a look on some integral property. The very important integral property here is minus a integral minus a to a fx dx is equal to 2 integral 0 to a fx dx. This is the very important integral property, students, which will be going to use in Fourier series. And this integral property, that is twice of integral 0 to a fx dx, is possible is only if the given function is even function, and this property will be 0 if the given function is odd function. Now you might be thinking that how you will be identifying that the given function is even function or odd function. It is very simple. What is even function? A function is said to be even function if and only if f of minus x is equal to fx. What does it mean? Like we have given a function, and after changing the value of the variable to minus, then after solving that particular function we will be getting the same function, then that function is said to be even function. You can see the example here, that is function x square, right? And after changing the value of the variable, that is x to minus x square, and after solving this variable we are getting the same value. Therefore the given function is said to be even function because after solving the variable we are getting the same function. Similarly, a trigonometric function cos x is also said to be a even function because after putting the negative value on the variable we are getting the same value. That's why cos x is a even function. Same wise, odd function. A function is said to be an odd function if and only if f of minus x equal to minus of fx. Right? Example, fx equal to x cube. Then f of minus x equal to minus x cube. Then we get the value minus x cube. So this function is said to be a odd function because we are getting the opposite value. Likewise, we have the trigonometric function, that is sin x, which is a odd function because we are getting the opposite value for solving the equation. Now let's see the by parts formula, which is also useful in solving the Fourier series. This formula you might have learned in 11th standard, that whenever we are getting the two functions, how to solve those integrals, like integral of f1x and f2x dx. So how to solve this integral? First function will be as it is, then integral of second function, then minus integral and differentiation of first function and integral of second function dx. So like this, we solve the two functions by integration, right? Now we have a very important rule here, that is a chain rule. This is very useful and very easy to solve two functions easily in a single step. That's why this chain rule of integration we will be going to use in yes, in solving the Fourier series. So what is this chain rule? Suppose if we are given two functions in which one is algebraic function and the other is trigonometric function, right? So how we will solve these functions? See, example, we are given x square sine 2x dx, right? So how to solve this? The first function, that is x square, will be as it is. Then integration of second function, that is sine 2x. So the integration of sine 2x is minus cos 2x upon 2. That is the coefficient of x is 2, that's why upon 2. Now then minus sign, after that the differentiation of x square, it is 2x, and the integration of cos 2x by 2, that is sin 2x by 2, and minus sign will be as it is because the integration of sin cos 2x will be sin 2x, and the coefficient of here 2x is 2, and this 2 get multiplied by 2, that's why it is 4. Then after minus sign we'll have plus sign. Likewise we have to do, like first is plus sign, then minus sign, then plus sign, then minus sign, then plus sign, like this. Then plus sign, then after differentiation of 2x will be 2, then integration of sine 2x will be minus cos 2x. That's why that minus and minus will be plus, that's why cos 2x by 8, because the coefficient of 2x, it is here, it is 2, and 4 into 2 4 into 2 it is 8. Now after solving this we'll get the value minus x square cos 2x by 2 plus 2x sin 2x by 4 plus 2 cos 2x by 8, right? Now limitation of this chain rule, we can use this chain rule only in the below forms. That is, if you have given the function in the form x to the power n cos x, then x to the power sin n x, and x to the power n e to the power x. These are the three forms. So in those below forms we will be going to use this chain rule. Now, what is Fourier series? Let function fx is defined and periodic in the interval a to b. Then its Fourier series is given by fx equal to n naught by 2 plus summation n equal to 1 to infinity n cos 2 n pi n x upon b minus a plus bn sin 2 n pi x upon b minus a. So here we have to find the parameters a naught, an, and bn. So how to solve the parameter a naught, bn, and n? A naught equal to 2 upon b minus a. Here b is upper limit and a is lower limit. Integration a to b fx dx. Fx is the function, whatever the function that we will be we have given, we'll put here. And then after an is equal to 2 upon b minus a integral of a to b fx cos 2 n pi x upon b minus a dx, and bn equal to 2 upon b minus a integral a to b fx sin 2 n pi x upon b minus a dx. Okay, so likewise we are going to solve these parameters node A and B, and after solving this parameter, we'll have to put the values of this parameter in the Fourier series. Okay. Now let's have a look on one problem Fourier series, that is fx equal to x square, right? So first of all, we have to solve b minus a. So here, what is b and a? Here a is minus pi and b is pi, right? So how to solve this? Here b minus a is pi minus minus pi equal to pi plus pi equal to 2 pi. So the value of b minus a is 2 pi. So we will put this value of b minus a in the Fourier series. So Fourier series of fx in the interval minus pi to pi is given by. In the previous slide, what we did, we have written the Fourier series in the interval a to b, but here we are finding the Fourier series in the interval minus pi to pi. So what will be the Fourier series in the interval minus pi to pi? That is fx equal to a naught by 2 plus summation n equal to 1 to infinity n cos 2 n pi x upon b minus a. B minus a here is 2 pi, right? Thus we have solved the value, and plus b n sin 2 n pi x upon b minus a is 2 pi, right? So after solving this, what we will get, a naught by 2 summation n equal to 1 to infinity n cos nx. See, in the above equation, 2 pi will be cancelled by 2 pi. That's why we are getting here cos nx plus bn sin, same like bn sin nx, because 2 pi will be cancelled by 2 pi. So mark the equation as a equation 1. Then after, this is our final Fourier series, right? So after solving the parameters of a naught a and b, and we are going to put those values in this equation. There is an equation 1. Now let's solve the equation a naught. A naught equal to 2 upon b minus a to b fsj, right? So put the value of b minus a and b in the equation. 2 upon b minus a is 2 pi, and a is minus pi and b is pi. Fx is our function x square dx, right? So 2 will be cancelled by 2, then we'll get the value 1 upon pi minus pi to pi x square dx. Now we have learned one definite integral property, that is integration minus a to a fx dx equal to twice of integral 0 to a fx dx, right? So we are going to use those integral property here. So 1 upon pi twice of integral minus pi to pi becomes 0 to pi x square dx, right? Then after solving this parameter 2 upon pi, the integration of x square is x cube upon 3, right? The power will be added, 2 plus 1, that is 3, x cube by 3, and what is the limit here, 0 to pi. Then after putting this limit, the equation 2 upon pi, pi cube upon 3 minus 0. Sorry, ignore this limit here. After solving this, so 2 pi is, then after solving this, what we'll get, that pi will be cancelled by this pi. That's why the final answer will be 2 pi square by 3. So the value of n will be here 2 pi square by 3. Now let's solve the value of n equal to 2 upon b minus a, integration a to b fx cos 2 pi mx upon b minus a dx, right? So n equal to 2 upon 2 pi x square cos 2 and pi x upon 2 pi dx. Now here students will be going to use the chain rule, because the first function is the algebraic function and the second function is the trigonometric function, that is, it is in the form of x to the power n cos x. I have shown you the three forms, right? So in which this forms is fitted here, that's why we are going to use the chain rule here, right? So how to solve this? N equal to 1 upon pi to integral. Here we have used the property, definite integral property, 0 to pi x square cos. Now here 2 pi will be cancelled by 2 pi, that's why x square cos nx dx. Now here we will be going to use the chain rule. N equal to 2 upon pi x square. What is the integration of cos nx? That is sin nx, right? and the coefficient of nx is n. That's why here it is n. Now now minus sign differentiation of this. Now here it is minus sign differentiation of x square will be 2x, and the integration of sin nx will be minus cos. That's why it is minus cos nx. The coefficient of nx it is n. So n into n will be n square. Then plus sign the differentiation of 2x, here it is 2, right? And the integration of cos nx will be sin nx. That's why here it is sin nx upon n cube, because the coefficient of nx is n into n square will be n cube upon the limit will be 0 to pi, right? Then after putting the value limit, that is 0 and pi here, pi square sin n pi by n plus 2 pi cos n pi by n square minus 2 sin n pi by n cube minus 0, right? Because the value of x square will be, x will be 0, that's why this term will be 0, this term will be 0, and this term will be 0. Since we know that the value of sin n pi equal to 0 and cos n pi equal to minus 1 to the power, right? So we'll put the value of sin n pi and cos n pi here, and what we'll get, 2 upon pi. The value of sin pi will be 0, that's why it is 0, plus 2 pi. The value of cos n pi is minus 1 to the power n upon n square will be as it is, and minus 2 into sin, the value of sin n pi will be 0, that's why it is 0. Then after solving this, what we'll get, n equal to 4 into minus 1 to the power n upon n square. This is our third equation. A naught will be our second equation and n will be our third equation. Then after finally we will find the value of bn. The formula for bn is 2 upon b minus a to b integration fx sine 2 n pi x upon b minus x, b minus a dx, right? So we'll put the value of b minus a here and the value of a to b here and function. Then after that, just we have used the definite integral property, that is 1 upon pi twice of integral 0 to pi x square sin nx dx. Now here, as we know that sin nx is the odd function, right? Sin nx is the odd function, hence the value of sin nx will be 0. That's why the integration 1 upon pi into 0 will be 0. So the value of bn will be 0. Now we will put the value of a naught and bn in equation first. That is in the Fourier series. What we will get, a naught by 2 plus bn. This is our Fourier series in the interval minus pi to pi, right? So we'll put the value, and finally we'll get the our Fourier series. That is pi square by 3 plus 4 into minus 1 to the power 1 upon 1 square cos x plus 1 square upon 2 square cos 2x minus 1 cube upon 3 square cos 3x plus and so on. So this is our required Fourier series. Okay, student. So that's all about the today's session, and in the next session we'll discuss on some more problems, and we'll discuss about the Fourier transform as well. Thank you, student.